Okay, excellent. It actually recorded. So let's continue on and see if we can have the second half actually record as well here. So now you have kind of an overview of how the carboxylic acid derivatives are all the same and how they react in a mechanism that is a two-step mechanism, which is acyl substitution, addition followed by elimination. So let's look at some of the other arrows that I have put over here on your pink sheet. So we can interconvert between a carboxylic acid and an acid chloride. Any of these acid derivatives, we can add water to them and they go back to the carboxylic acid when water is acting as a nucleophile. We can convert a higher energy carboxylic acid chloride into an anhydride. By adding the appropriate nucleophile, we can convert an anhydride to an ester by adding the appropriate nucleophile. We can convert an ester into an amide by adding the appropriate nucleophile. And we can also convert then an acid chloride easily into an ester, or an acid chloride into an amide, or an anhydride into an amide. And so it's pretty easy to go from a higher energy carboxylic acid derivative to a lower energy one by adding the appropriate nucleophile. And again, it's the same reaction, same mechanism overall, with the nucleophile kicking out the leaving group. So let's talk about if we wanted to synthesize one of these carboxylic acid derivatives. We will start originally for any carboxylic acid derivative from a carboxylic acid. You recall the methods that you have learned for making a carboxylic acid. If you want to simply oxidize a primary alcohol, you can do that with a strong oxidizing agent, chromium trioxide, permanganate, dichromate. If you want to add an extra carbon, you can start with a shorter chain, one carbon shorter, an alkyl halide. You can convert it into a Grignard reagent and add carbon dioxide, followed by hydrolysis. Or you can add sodium cyanide and then hydrolyze that nitrile to the carboxylic acid. So this is how you would be working on making carboxylic acids. Then, once you have a carboxylic acid, there are standard ways in which you could convert that into each of the other functional groups you see on the right. The standard way of making a acid chloride from it is to add thionyl chloride, which is a high energy source of chloride, the thionyl chloride making this poor leaving group into a better leaving group. You've already seen thionyl chloride for converting alcohols into halides, into chlorides, and it's doing the same thing here. So this is how you would make, in synthesis, this is how you would make an acid chloride. If you wanted to make an anhydride, then the standard way would be to convert first to a carboxylic acid chloride and then add the other portion of the anhydride as the carboxylic acid. And so this would be the nucleophile. This would act as a nucleophile attacking the carbonyl here, and the acid chloride would be the electrophile. So that's how you would make an anhydride in the standard way. You can also make it here by reacting two acids together, but they would have to be the same carboxylic acid, giving a symmetrical anhydride here. Otherwise, we get mixture of three different actual anhydrides here if these two acids were different from each other. If we wanted to make an ester, the standard way to make an ester is to do what is called Fischer esterification, and that is to start out directly from the carboxylic acid, add the alcohol in the presence of an acid catalyst, and you would need an excess of the alcohol to drive the equilibrium to the right. Notice these are both on the same energy level, and so you're not going to favor the ester unless you remove the water that's formed or you add an excess of one of the reagents, which would be the alcohol, which you typically use as a solvent. You are familiar with using alcohols as solvents from your first research project, and they're cheap, and so to add an excess of the alcohol would not be a problem. So that's the standard way to make an ester. Standard way to make an amide is to make the acid chloride first and react it with the amine to get to the amide, and that avoids the problem that you run into when you have an amine and a carboxylic acid together. You have an acid and a base, and so in competition with the amide formation, we are actually in a much quicker reaction doing the acid-base reaction, turning this into a carboxylate and this into an ammonium ion. So these are the pathways that you will follow in synthesis. You want to make an amide, you make it from an acid chloride, which you make from an acid. You want to make an ester, you typically esterify the acid directly. If you want to make an anhydride, you make the acid chloride and then react it with the carboxylic acid. And if you want to make the acid chloride, you make it from the acid using thionyl chloride. So this ends the overview of reactions of carboxylic acid derivatives.